Welcome to On Chemistry. Always try to do your best. Now, let us see about 100 concepts in organic chemistry. We are seeing it as episode. This is the episode number 76. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the first question. They given the 3 different heterocycle. First one is pyrrole, second one is thiophene, third one is pyridine. They are asking reactivity towards electrophile. So you have to find the electrophilicity among them. So you have to find which one is higher, which one is lower, which one is on middle. From the question of heterocycle and the reactivity towards electrophile, you might realize the question is really about heteroatom versus ring size versus reactivity. The answer is D. Let us see how. The answer will be easy if you know the facts. High electron density means high reactivity. Here, the electron density of 5-member ring definitely higher than 6-member. Because you have same 6 electron in 5-member mean the density ratio is higher there. So if you look at it, 5 members only have high reactivity, so third will be the least one. You have to look between amine and sulfur. Amine is more electrophilic than sulfur because the sulfur, it has d orbital and carbon. What really happens is carbon-sulfur bond is not effective, so the contribution of lone pair is not effective in the resonance. Basically, the delocalization is less, so aromaticity is less, so electron density is less. So it will be less electrophilic than 1. So if you look at the order, 1 will be higher, then will come 2, then the third will come. Here the concepts you have to learn here is higher electron density means higher the reactivity for the electrophilic reaction. Then let us look at the next question. They given the 3 different isomers. They are structural isomer. One is orthodichlorobenzene, B is metadichlorobenzene, C is paradichlorobenzene. 3 different chlorinated compound. Here they are asking number of C13 signal. You have to find from broadband T-coupled NMR. Here the answers are basically playing between 342 or 332 or 442 or 344. So from the question of structural isomer to NMR signal, you might realize the question is really about symmetry versus NMR signal. The answer is A. Let us see how. The first step of identification of signal is identifying the symmetry. So all 3 compounds we have to write symmetry elements. If you look at the A1, it has plane of symmetry. It bisects near the 2 chlorine atom. So it has 3 signal A, B, C. So the reflection side will have same signal, so it has only 3. If you look at the B1, it has plane of symmetry and it has 4 signals. The plane of symmetry indicated as dotted line. The line which is in the middle, it has A1, then the B come chlorinated, then C, then D. Totally 4 signal. If you look at the C, it's the most symmetrical one. It has 2 plane of symmetry. Since it has 2 plane of symmetry, it has only 2 chemical shift, which is chlorine attached one and the nearby one. So the answer is A. A has 3 signal, B has 4 signal, C has only 2. Here the concepts you have to learn here is more symmetrical compound give less number of signal and less symmetrical compound give more number of signal. Then let us look at the next question. They given the highly conjugated compound with 3 fused kind of ring system. The first one is with 2 bridged carbon, second one is with 1 bridged carbon, third one without bridged carbon, and fourth one kind of naphthalene analog. So 4 different compound. They are asking aromatic compound among these. So the choices can be anything. So basically you have to play between the Huckel rule and analyze the conjugation and analyze the pi electron. So from the question of 4 different structure and aromaticity, you might realize the question is really about the bridged carbon influence versus aromaticity. The answer is A. Let us see how. Here the aromaticity is dictated by the hydrogen and planarity. Here the hydrogen creates the steric effect which indeed prevent the planar structure. If it is not planar, no resonance will be there, so it is not good for aromaticity. We can call it as non-aromatic. If you look at the second one, two steric hydrogens are there, structure is not planar, hence non-aromatic. If you look at the third structure, it has 4 steric hydrogen, definitely forced to be non-planar and it is non-aromatic. If you look at the fourth one, that's also having 2 steric hydrogen, it is forced to be non-planar, non-aromatic. The only aromatic is first one. The hydrogen atoms are compensated by methyl group there, so no steric effect, hence it is planar. It has 4n plus 2 pi electron, totally 14 pi, so it is definitely aromatic. So the answer is clearly A there. Here the concepts you have to learn here is steric effect influence the planarity of the compound. Basically the hydrogen steric effect. Then let us look at the next question. The starting metal is cyclohexane with amine and alcohol in transposition. You are using nitrous acid. They ask you to find the product. The products can be a ketone, or the ring contracted aldehyde, or the alkene alcohol, or the bridged oxide, which is epoxide. So you have to find how the starting metal and reagents are react. So you have to find the influence of reagent and the reactant. So from the question of different starting material and stereochemistry and 4 different possibilities, you might realize the question is really about reagent versus ring contractions. The answer is B. Let us see how. Here the starting metal is cyclohexane with amine and alcohol in transposition. So you have to draw in the chair form for better understanding. It can be drawn in 2 ways. One is both in axial form, both in equatorial form, but both in equatorial is stable due to the less steric influence. So that line will be the major product. If you go through all axial form, first step is N2 plus is formed, then the OH assists the N2 leaving, it form epoxide. But in all equatorial form, same thing form, but the trans group migrates. Trans group is methylene group, so ring contracted, you have ketone formation. So since equatorial is more stable, the ring contracted product is major here. That's why the answer is B there. Here the concepts you have to learn here is trans group assists the leaving group here. In the first one, OH is trans, second one methylene is trans. Then let us look at the next question. They are asking pair of resolved configurational isomer. They given the cis 1,2 dimethyl cyclohexane, cis 1,3 dimethyl cyclohexane, cis 1,4 dimethyl cyclohexane and trans 1,3 dimethyl cyclohexane. Basically we are playing between the methyl groups here. So from the question of resolvability and 4 different structural isomer, you might realize the question is really about symmetry versus resolvability. The answer is D. Let us see how. Here you have to know how to draw the stable form of cyclohexane. The 1,2 form in your draw cis, meaning both axial and equatorial are the same cis fashion. So if the ring flips, you will also having same. It will be difficult to resolve there since it has C2 symmetrical relationship. If you rotate it, you will have the same. If you look at the B, it's cis 1,3 dimethyl cyclohexane. It has central mirror plane of symmetry, so the mirror plane is resolvable. So the mirror plane creates the optical inactivity, it's difficult to resolve it. If you look at the C, it's again 1,4 dimethyl cyclohexane, again it has mirror symmetry, so it is not resolvable. If you look at the D, trans relationship of 1 and 3 doesn't have any symmetry there, so definitely it is resolvable. So you have to find which one have mirror symmetry, which one don't have mirror symmetry. So the answer is clearly D there. Here the concepts you have to learn here is the compound with mirror image or axis of symmetry. Definitely you can't resolve it. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.